This webinar explains how to set up test conditions according to the various standards and how to read the data from the test result. Material testing is often carried out with reference to conditions in accordance with various industrial standards. Industrial standards refer to arrangements for industrial standardization, which aim to establish national-level standards as technical documents to ensure quality and compatibility, and to unify products and services, and are published as technical texts. Industrial standards cover a wide range of topics, from definitions of various materials and terminology to test equipment and test methods. So, when you are required to test your standard, make sure you check the latest version of the standard. The following section introduces some representative industry standards. First, ASTM is a standard developed by the American Society for Testing Materials, and although it is a standard by a private organization, it is widely used in materials testing worldwide. Second, ISO is a standard developed by the International Organization for Standardization and includes international standards for food, medicine, and services as well as industrial materials. Finally, JIS is defined by the Japanese industrial standards and is cited as a technical standard in many Japanese laws and regulations. They all describe the conditions required to perform a strength test, such as test speed, specimen shape, and gauge length, and whether or not an extension method is used. These standards may have different requirements for testing the same material, so it is important to check in advance which standard to use. In recent years, efforts have been made to harmonize these standards. Here, an example of tensile testing of metal according to JIS Z 2241, which is based on the ISO 68921, is presented. Standards describe the test conditions for the material to be measured. Let's take a look at the conditions described in JIS Z 2241. Firstly, the test speed parameter is explained. In JIS Z 2241, the test rate is specified for each physical property of the metal to be measured. In addition, there are several ways to control the test speed: stress rate control and strain rate control. Stress rate control is a control method where the rate of increase of the stress applied to the test piece is constant, while strain rate control is a control method where the rate of increase of the extensor strain applied to the test piece is constant. These should be selected according to the physical properties to be determined and the instrument configuration used. Next, the shape of the test piece to be measured is described. The shape of the test piece is defined in detail according to the type, shape, and dimensions of a material to be measured. For example, a dumbbell-shaped test piece with a narrow center is used for common thin-sheet materials. The extensor used to measure strain are specified in terms of grade, which are classified according to whether they are used or not and the extent to which their accuracy is granted. Here are the results of tensile test on high-strength steel plates. In this test specimen, SPFC 980, which has a strength of more than 980 megapascal, was tested using hydraulic flat gripper for stable gripping on high-strength steel plates. This test case showed a tensile strength of 982 megapascal. In addition, the elastic modulus calculated from this result was 199 gigapascal. The following is an example on the tensile test on plastics in accordance with JIS K 7161 plastics. Determination of tensile properties based on ISO 5271. For resins such as plastics, there may be variation in the strength values obtained depending on the test speed. It is therefore preferable to use a raw test speed when measuring the elastic modulus, where the measurement range is between 0.05% and 0.25% of strain. On the other hand, if the test speed is set at a raw value, the plastic can stretch before it ruptures, so the test speed is often increased after the modulus is measured to determine the strength value. In this test, 3 different test species, polypropylene, polycarbonate, and polyvinyl chloride were tested in tension, with modulus values ranging from 1.66 to 3.23 gigapascal and strength value from 32 to 73 megapascal. The results show that the physical properties of each material are different. The following is an example of a rubber tensile test in accordance with JIS K 6251 rubber, vulcanized or thermoplastic, how to determine the tensile properties based on ISO 37. In this rubber test, a pneumatically operated gripper is used in order to grip the test piece, as the area where the gripper contact is likely to be cut, and the extensometer is a JIS 1000, which can be used to measure soft materials. In this case study, chloroprene rubber and 2 types of urethane rubber were tested. In addition to strength and elongation at break, rubber test sometimes determines the stress at a given elongation, and the stress at 100% elongation and 200% elongation are also shown here. Following is an example of tensile testing of carbon fibers according to JIS R 7606 carbon fibers, tensile properties of single fibers, which is based on ISO 11566. Carbon fibers are embedded in matrix resins such as resin and used as composite materials. Carbon fiber reinforced plastics, in which carbon fibers are used as a reinforcement, have very high specific strength and specific stiffness. A single carbon fiber is like the lead of a mechanical pencil, but only about 2% as thick. It is very brittle and therefore difficult to grip directly with a jig. For such a specimen, tests are sometimes carried out by gluing the specimen to a paper frame, gripping it with the jig, and cutting the side of the paper frame. Next, a case study of a bending test is described. Here we present an example of a bending test on the plastics in accordance with JIS K 7171 plastics, determination of flexual properties, which is based on ISO 178. Here is a case study of a bending test carried out on the polypropylene, polyvinyl chloride, and GFRP. As with the tensile test, the test speed was set to raw until the modulus was measured, and then the test speed was set to high for the transition. The standard state, the span between the test specimen and the supports should be 16 times the specimen's thickness. In this case, it was 4 mm thick, so the test was carried out with a distance of 64 mm between the supports. In order to accurately measure the bending deflection of the specimen in this test case, the standard state, a bending deflectometer should be used that meets the measurement accuracy calculated from the specimen's thickness. For this reason, a contact-type bend deflectometer was used in this test to meet this accuracy. In many cases, the specimen does not rupture in bending test, and the test is often terminated after the bending strength, which is the maximum stress, has been measured. Next, The adhesive test peer test according to JIS K 0237, determination of peer adhesion properties based on ISO 29862 is introduced. The adhesive test is attached to a metal test plate on the underside of the test jig, and one end of the tape is gripped by the gripper on the underside of the test jig. At the start of the test, the underside of the jig moves in conjunction with the crosshead so that the tape can be peeled off at a peer angle of 90 degrees until the end of the test. Finally, tests to evaluate the texture of foods are presented. Here a texture test of care food is shown. The evaluation of the texture of care food is very important because the safety of food depends on the ease with which it can be eaten and swallowed. For this reason, there are several evaluation standards for nursing care food. In this section, we present an example of the test according to the test method for food for people with swallowing difficulties, which is one of these standards. In the test board approval standard for food for people with feeding difficulties, the food is placed in a metal petri dish 40 mm in diameter and 50 mm high and crushed twice from the top to the specified depth with a probe 20 mm in diameter. The results are shown in the graph on the right. The graph is called the texture profile, with the total distance traveled by the probe on the horizontal axis and the test force on the vertical axis. From the texture profile, indices such as hardness, adhesion, and cohesion can be calculated, and these are used as the result of the nursing care food evaluation. The following table shows the result of testing commercially available nursing care foods. A universal design food test kit was used as a jig, which can test the approval criteria for food for people with dyspnea and the standards for universal design food. The hardness, adhesion, and cohesion were evaluated, and the approval for this product as a care food was all three, corresponding to a pureed swallow food. This webinar explained the following things. The various industry standards are often referred to when performing strength tests. The standards describe the conditions required to perform a strength test, such as test speed, test piece shape, and gauge length, and whether or not an extensometer is used. The standards are divided according to the material and the purpose of the test.
Excellence in science. Shimadzu.